Hey, hi, hello guys, welcome back to my channel Code with Nani. Today we're going to discuss about control statements, if else, switch case, and ternary operator. Let's talk about this if else statements, control statements. So, what are the control statements? So, control statements are the statements like that checks the validity of that particular condition. So I'll give an example. Suppose we want to check whether the person is eligible for voting or not. Like suppose if what is a valid eligible voting? It is 18 years. So we'll check whether the person is 18 years above or not. If he is above 18 years, then he is eligible for vote. Otherwise, he is not eligible for vote. So that's how the control statement works. Like it will check or validate the particular condition, and based on that particular validation, it will enter it into a if else statements. I'll give an example. Let's say int age, and it'll take the input value as C in age. So if age is greater than or equal to 18, then see out he is eligible. Else see out not eligible. Right? So that's how it works. So if there are multiple cases, like we are using, there was only two condition. If it is greater than 18, then eligible or not eligible. There may be a case there will be have a different if else checks. Like if we want to check whether it is a if the number is a three-digit number or more than three-digit number, right? So how do we check? So if num is less than 9, then out single digit, right? Single digit. So else if, so before it's just if and else, so we have a different more number of cases, then we use else if num less than 99, then means it is a double digit number, as we already checked for single digit. So if number is greater than 9 only, it will comes to else if, otherwise it will just see out the single digit. If the number is more than 9 and it is less than 99, then else if will be executed. Then what we will say? See out two digit, right? And else if num less than triple nine, see out three digit. So how does it works? How does it works? If whatever that, if let's say number is 10, so it will goes to this first if statement as num is greater than 9, so this will not be executed. Look, let's take another case, else out more than 3 digit. So let's take an example, num is equal to 10. So it will comes to this if statement as num is greater than 10, it gives false statement. It is false, so it will not be executed. The num comes here as num is less than 99. So what it does is it counts two-digit number. Exactly, 10 is a two-digit number. That's how it works. This is a simple if else. Simple if else, and this is nested if else statements. So this is the theoretical part regarding if else statement. I will walk through you some of the basic examples so that you can get hands on it if else statements. So before that, I'll show you. some of the examples. Let's take C++ non-compile. What got this? Sublime text. I'm using Sublime Text to run locally on my machine. If you don't have this Sublime Text on your machine, do check it out my DSA channel. Yesterday I posted a video regarding how to install Sublime as well as MinGW on my channel, or even you can see that in my description of my channel. Do check it out and install it on your local machine. So let's get started. So let's take example. So in age, right? So in age. So if age is greater than or equal to 18, CL zero, right? Otherwise, not eligible. Control P and go to Olympic code and run it. So these are the old test cases which I did yesterday. Let's just delete everything just for next test case. So I'm giving age as 30 years. So he is eligible for the vote, right? So see, it is eligible. And let's check for another example. 15, he's not eligible. So it's not eligible. So this is the classic example of the if else statement. Uh, let's check. Let's check for the program if a number is even or not. Right. Let's check. Check your number is even or not. So how do you check whether a number is even or not? As I told you, did you remember? As I told you, we have an expression called modulo, right? So what does it does? Checks remainder. So when do we say it is an even number? If a number is divisible by 2 and if it gives remainder 0, then it is an even number. Let's take an example. 8. If we divide with the 2, 4 are 8, which indeed gives 0. So it is an even. So if remainder is 0, when it is divisible by 2, then it is an even number. Let's take an example. 9. 2. 2 4 are 8. And it giving 1 as a reminder. So it is not an even number, it is an odd number. So that's how it works. So we'll use a modulo operator and check whether the number is an even or not. Let's check the example. In num, say in num, if number is divided, this is a reminder operator. So when the remainder is equal to 0. So what is equal to represent? It will check for the LHS and RHS whether both are equal or not. So in the mathematics we have equal to operator, right? This 2 is equal to this 2 or not. So in the computer science or computer programming languages, we use single equal for assigning the value, and double equals to check whether LHS is equal to RHS. So that's what we were doing. So whenever this number modulo divided by 2. Like whenever we get a remainder with 2, if it equal to 0, if this gets 0 as LHS equal to RHS, will return even number, right? Suppose take 8 modulo 2, which gives remainder 0. So 0 equal to 0, as it is 2, then it is remainder 2. Remainder, it will gives even number. Otherwise, we'll print as odd number. So 2, say out 8 is an even number. Right? Else, say out 7 out. That is fine. So just give a test case like 19. 19 is an odd number. See, it gives you the 9 odd number. Let's take another even number like 100. It is an even number because it is divisible by 2 and it will use the remainder 0 when it is divisible by 2. That's why 100 is an even number. So we know how to do an even odd number, how to distinguish using modulo operator. So let's check another things. Yeah, let's check for the relation operators. Int a b. We are like declaring the variables, two variables a b, taking input as a b, taking two variables a and b, and taking a cn, using the cn we're taking in the values a and b. So if a greater than b, what we need to print out, see out is greater, right? Else if b greater than a, see out b is greater. And there may be another case when both are equal. So we have to mention in the else case. Else here a is equal to b. Let's check that part. Check another case. Let's give a as 12, b as 15. So in this case, 15 is greater than 12. So indeed, b is greater than b. B is greater than b is greater. Yeah. Let's give another example. 12 and 12. Both are 12, which means a equal to b. A is equal to b. So that's how we get it. That's how the logical operators, relational operators works. So we have tried relational operation language. Then we'll take an example for the logical operators as well. Let's take another input C. Okay. And we're taking the input values for C as well. So what I told you, and which means LHS needs to be true as well as RHS need to be true. For the OS case, any one of this is true, then it will be totally, this will become true. If both are true only, it will become true. Okay. keep this in mind. Let's check if A greater than B and B greater than C, which means logically if A is greater than B, which means if A greater than B as well as A is greater than C, which means A is greater than B and C, right? So here A is greater. Here also if not that the thing A is also if B greater than C or B greater than A, then C out B is greater. Yes, else C will be the greater. C is greater. Yeah. Save it, run it. So three cases. A will be 12, B will be 2, and C will be 11. So out of all this, A is greater, right? It is greater than B as well as it is greater than 3. So that's why we're getting A is greater. Let's take another example. 1, 3, 0. A is greater. So that's how the logical operator works. And then if we say or here, A is greater. If we say or, if A is greater than B, or if A is greater than C, A is greater than one number, right? It is greater than any of that number, right? Yes. See out, because if it is not greater than any of the other number, it means it will be the smallest element, right? So else I will print this. It is smallest. Let's run this code. Suppose 12, 15, and let's take another value as 3. So here A is A 12, which is greater than 3. So it is, yes, indeed it is greater than any of that B or C. So definitely it will print as A is greater than one number. So if we take 12, 12, and 12, it is not greater than any of the numbers. So C will be the smallest. It is the smallest. So that's how it works. So how does or operator works is if any of this left hand part or right hand part is true, then the total expression of this if will be true, and that statement will execute. And how and works, if left hand part as well as right hand part true, then totally will, if block will be true, then that if statement is executed. That's how and or operator works. Cool. So yeah, bitwise you'll come across later. Right now it doesn't, really necessary. Then comes assignment operator. We all know this assignment operator where we are, assigning the values A equal to 2 or A equal to A plus 3, which means this 2 is appended here and it will add 2 plus 3 and it will store the 2 plus 3 in the variable. That's how assignment operator works. And I will show you the ternary operator. So as we all know, we checked age of the two people, right? Int age, in age, if age greater than or equal to 18, see out, eligible, right? Else, not eligible. So that's how it works. So the ternary operators consist of three operators, three expression are, as I told you earlier. So this is the condition, and this is expression 2. I'll show you. Expression 1, expression 2, expression 3, right? So just implement the same thing as we implemented using if else. So we can use this ternary operator instead of simple if else statement. So what is the condition here? Age is greater than or equal to 18, right? If that is the case, expression 2 will be executed. If age is greater than 2, expression 2 will be executed. So what is expression 2? See out eligible, right? If not, after the colon, semicolon, it will be executed. If age is not greater than 18, not eligible. So that's how ternary operator works. So instead of this if else statement, we can just make use of this single line ternary operator. It does exactly the same functionality of this if else statement. So just delete this. I'll check for that. Okay. You cannot directly incorporate. It's the same. So we're just using cout. Just so we're just using cout as the main statement and using condition if age is greater than or equal to. If it is true, just using eligible to print. As we have a cout, it will just print out the eligible. If it is false, then not eligible will be executed. So that's how it works. As earlier, we are using this semicolon over here. That's why it generates output. So we shouldn't use semicolon in between this ternary operator. So that's how. Let's just go inputs. As age is 20 years, he's eligible, right? Yeah, it does the same, exactly same functionality as if else statement. And if his age is 17 years, he's not eligible. So how do we distinguish whether an year is leap year or not? Leap year or not? We'll just quickly finish this example and we'll wind up this session. How do we How do we distinguish whether a year is a leap year or not? So how do we do? Just think for a minute. We'll use the same modulo operator here over here. Modulo operator. Modulo operator over here. So how do we use modular operator here? So leap year is an year. Leap year is a year exactly divisible by 400, which means if it is divisible by 400 and gives the remainder, then it is a leap year. Okay. So and there may be other case. If it is not divisible by 400, then it doesn't mean that it is not a leap year. Still, there was a cases. Else, if it is year modulo defined by 100 equal to 0, then indeed it is not a leap year. Also, there's a case year modulo divided by 4 equal to 0, then it is a leap year. So let's just write down everything in a single line. If year modulo divided by 400 equal to 0, year modulo by 4 equal to 0. In these two cases, it is a leap year. And if it is year modulo divided by 100 is equal to 0, not a leap year. Okay, so these are the conditions for this leap year program. Leap year program. We'll just go into this. And here, in here, if year modulo by 400 is equal to 0, then just print out cout it is a leap year. Else, if year by 100 equal to 0, then it is not a leap year. So it is not divisible by 100 doesn't mean it is not a leap year. If it is not divisible by 400 and it is also not divisible by 100, and if there is another case, we'll check for. Else, if year modulo 4 equal to 0, then it is a leap year. Else, just print out it is not a leap year. So these are the things, like if a year is divisible by 400, which is it gives remainder 0, then it is a leap year. If not that case, and if year is completely divisible by 100, then it is not a leap year. And another case, if it is an year divisible by 4, then it is a leap year. Else, we'll just return as not a leap year. Check 2012. Let's go for this. Let's test yes. 2012. Yes, it is a leap year as it is completely divisible by 4. 2000 is a leap year. 2011. It is not a leap year. We can even make more efficient this way. Just use logical expression as we know year is completely divisible by 400 as well as 4, then it is a leap year. So we'll just write out and year divisible by 400 equal to 0. Just put these braces. Let's take this as an important note. Like after every logical operator, use this brackets because these will distinguish associative between other operators. Like if you want to use this on another operator, we'll just put this in a brackets. Or so let's just erase this because we already included that. And if when it will be a leap year, if it is not if it is divisible by 100, then it is not a leap year. When does it will be a leap year? If it is not divisible, right? If it is divisible by 100, it is not a leap year. When if it is not divisible by 100, then it definitely will be a leap year, right? So I'll use or year percentage 100 not equal to 0, then it is a leap year. So we already included these two. So this comes under a single line of whether the given year is leap year or not. Just check shift P run check for 2012. So that's how it works. Wow. Thank you. So let's check for another case 2008. So that's it for the today video, guys. If you like the video, just share it with your friends, subscribe to my channel and hit that bell icon. And if you had any queries regarding this program or explanation, do comment in the comment section and I'll be there to help you out. So that's it for today video. Thank you. Bye bye. Signing off. See you tomorrow with your new content. Bye bye.